Hello everyone. I've had a few requests to go over the domain worksheet word problems. A few students were having a few troubles with them, so I figured I would go over a few on a quick video with you. Looking at number 17, it says, while visiting his grandparents for the first time in 15 years, Bob goes to collect some honey from his favorite honey tree, and instead collects a significant number of stings from the hive's new killer inhabitants. In his delirium, blundering Bob postulates that the level of pain in BPUs is a function of the number of bees that stung him, and the function is modeled by f of x equals 20 minus the square root of 400 minus 25x. We need to find the domain of f. Now if we look at this word problem, we can already tell that it is limited by this square root. So we will take our traditional approach and we will set this inside of the square root, the 400 minus 25x greater than or equal to 0, because the inside of the square root cannot be negative. We will solve this, so we will subtract 400 from each side. We will get negative 25x is greater than or equal to negative 400. We will divide by negative 25. Now remember, when you divide by a negative, the inequality switches, and we will get that x is less than or equal to 16. Now, what we also have to take into effect here, we have to further limit our domain by the word problem itself. Now, x is the number of bee stings that stung him. So, if we're thinking about it, the number of bees that stung him, he can't be stung by half of a bee, and he can't be stung by a negative number of bees. He can be stung by either 0 bees, 1 bee, 2 bees, on up to 16 bees. So that's how the word problem here limits our domain. So this 0 to 16, just the whole numbers, is our domain for number 17. I hope that makes sense. Number 18 here says, after her final exam, Cecilia climbs to the top of the water tower and throws her textbook with an initial upward velocity of 34.3 meters per second. The book flies through the air in a graceful parabolic arc, and after exactly 10 seconds of flight, it lands with a thud in a tar pit 147 meters below its release point. The function h of t equals 147 minus 4.9 t squared plus 34.3 t gives the height of the book in meters above the tar pit, where t is the seconds since the book was released. Find the domain of h of t. Hence, the function does not apply after the book hits the tar pit. Now, the initial function itself has no issues. Its domain would be all real numbers, but we are limited here by the problem situation itself. For one, we can't have negative time here. Time starts at 0. Now we can have 0 seconds, that's when the book's in her hand. But the book only flies for exactly 10 seconds. Then it hits the ground, and just like this says, after it hits the ground, the function does not apply. So our domain here is 0 to 10. It can be any time in between. Any time in between is able to be plugged into this equation and solved for. But it can't be any less than 0, and it can't be any more than 10. So that's how the problem situation here limits our domain. Let's look at number 19. If you have agreed to pay off a loan of $1,600 with $128 interest by making monthly payments of $144, the amount of money remaining to be paid on the loan can be modeled by the function b of x equals 1,728 minus 144x dollars, where x is the number of payments that have been made. We need to find the domain of b of x. Now, once again, the initial function here has no limitations. It has no square roots. It has no divisions to worry about. But the problem situation here is what limits it, the word problem. Now, if you're thinking about payments, the least amount of payments you can make are 0. And if we think about the situation here, we're not making half payments. We're having to make full payments. So we know the lower end, we're not going to make any negative payments. So we can start at 0. But we got to figure out how many payments we're going to make before this loan's paid off, because we're not going to overpay and give them money that we do not owe them. So let's figure out when this function actually equals 0 so we can see when this loan will be paid off, how many payments it'll actually take. So I'm going to set b of x equal to 0. I'm going to solve this function and see how many payments it's going to take to get it to 0. It's a pretty simple solve here. I'm going to subtract 1,728 from each side. And I'm going to get negative 1,728 equals negative 144x. Now I'm going to divide by negative 144. And we're going to see that x is, I believe it's 12, but I'm going to check my math on my side with a calculator real quick. Feel free to do the same on yours. Yep, it's 12. So we can make between 0 payments and 12 payments. No half or partial payments, just full payments. So that is our domain, 0 to 12. Only the whole numbers. Now number 20 says the cost in dollars of removing pollution from a smokestack of an electrical plant is related to the percent pollution P being removed according to the equation C of P equals 10,500 divided by 100 minus P. We want to know what is the domain of C of P. Okay, we are limited here because of our domain in the denominator. So we're going to take this denominator, and we know that it cannot be equal to 0. And what we find here, if we add P to both sides, is that P cannot be equal to 100. Now, kind of makes sense that our pollution is never going to be 0 if we're looking at the smokestack here. So that already makes a little sense in terms of the word problem here. Now, let's see if we can limit it even more. Now, the daily cost is your C, and the percent of pollution is your P. Now, what do we know about percent? We know percents range from 0 to 100, okay? And they can be anything in between. So here, 0 is a possibility for our percent, all the way up to 100. But we notice because of our domain and the denominator, that initial limitation here, that it's not going to be equal to that 100. So our answer here is going to be 0 to 100, but with a parentheses on the 100 instead of a bracket. We do have a bracket on the 0 because it's possible not to reduce the pollution at all. That wouldn't be a good thing though, now would it? Now 21 says market demand in thousands of units for digital cameras is given by the function D of P equals negative 0.2P plus 130, where P is the price per camera. Let's find the domain of P. So, market demand in thousands of units is given by this. P is the price per camera. Okay, now, when we're looking at this, they're not giving cameras away for free, I can tell you that much. So, market demand in thousands of units for digital cameras is given by this function. So, if P is the price per camera, I would say the lowest it could be, I guess, is 0. But, the highest it could be, I'm going to guess, is probably infinite. I mean, they could charge anything for these things. Now, your solutions down here show that the answer is 0 to 650. Let's see how they got that. So obviously, like I said, can't charge nothing for it, right? Let's see how they get that upper number. So number 21, on the answer key here, is 0 to 650. Market demand. Thousands of units. So, this is a tricky one. Had to read over it a few times. Now, the tricky part about this is you're thinking about market demand. Okay. Now, market demand is only going to ever be so high. So, if the price per camera is low here, you're going to have a strong market demand. But once that demand gets high, it's going to go to zero. And market demand can never be negative. The most it can be, or the lowest it could be, is technically zero. So if we set this equation here equal to zero, and we solve for P, so I'm going to subtract 130 from each side. I'm going to get negative 130 equals negative 0.2p. I'm going to divide by negative 0.2 on each side. And I'm going to see, let's see, I have to pull out my calculator on my side. You can check me if you'd like. 130 divided by 0.2, that's going to give me the 650. Awesome. So, the price is going to range from 0 to 650. Now, you know that they're not going to charge 0 for a camera. It's got to cost something, right? But the 650, they could charge that. But that would equal a 0 market demand, which wouldn't be very smart. Let's look at number 22. A factory's new training program for production teams allows each team up to but no more than 24 hours of training. The average time in hours that a new production team takes to assemble 1 unit of a product is given by h of t equals 5 plus 3t divided by 2t plus 1, where t is the number of hours spent training the team. What is the domain of the function h of t? Alright, well, we are already limited by the denominator. We know that it cannot equal 0. Can't equal 0 here. So if we solve this out, I'm going to subtract 1 from each side. Get 2t cannot equal negative 1. Divide by 2 here. I'm going to see that t cannot equal negative 1/2. Alright, so if we read back through the problem, factory's new training program for production allows each team up to but no more than 25 hours of training. The average time that a new production team takes to assemble 1 unit of product is given by this function. T is the number of hours spent training the team. Okay, we want to know what is the domain of the function. Now we did look at the denominator and it says time can't be negative 1/2. We already know that time can't be 1/2 because time can't be negative. We also know they can spend no more than 25 hours. So I'm saying here that the team could technically spend 0 hours getting trained. I think we've all had the job where we weren't properly trained or trained at all. It does happen that sometimes you get 0 training for a new job. And they can spend no more than 25 hours. So our upper limit here is 25. So that is going to be our domain for 22. Alright, the intensity of light is inversely proportional to the square of the distance from the source and is given by the function I of d equals 0.65 over d squared, where I is the intensity in foot candles and d is the distance in feet from the source. We need to find the domain of this function. Now obviously here, d squared cannot equal 0, which means that d cannot equal 0. You don't want your light touching your actual thing that you're looking at, right? You got to have some space here. That already makes sense. So here the intensity of the light is inversely proportional to the square of the distance from the source. It's given by this function where I is the intensity and d is the distance in feet from the source. What is the domain for this function? So if we know it can't be equal to 0, then we're going to use a parentheses on 0. Distance is obviously not going to be negative, so we can exclude that negative part. You can't go a negative distance for something. But you can forever move away from an object. So our upper limit here is going to be infinity. I hope this review here on the word problems has helped. If you have any further questions, please let me know. I will be available via email. Keep working hard this semester, and I'm here to help.